Hello friends, welcome back to my YouTube channel Math is Magic. Today, let us continue with the second question of exercise 1.2. But before solving the second question of exercise 1.2, we need to know an important formula. Let's see what it is. The important formula is LCM into HCF is equal to product of two numbers. Solving it further, we get LCM is equal to product of two numbers divided HCF. As we know, when HCF is in multiplication, on the other side it goes in division. And also, HCF is equal to product of two numbers by LCM. And also again, when LCM it is in multiplication, the other side it goes in division. Let us understand the formula in detail. HCF is equal to product of the smallest power of each common prime factor in the numbers, and LCM, which is equal to lowest common factor, HCF highest common factor. LCM is equal to product of the greatest power of each prime factor involved in the numbers. What they say is HCF is equal to product of the smallest power. If we take a two number and their prime factorizations, the HCF is equal to the number which is in common, which is in both the prime factorizations of the number, and we need to take the smallest power of the common number. In the case of LCM, it is a product of the greatest power. So, in this case, we need to take the two numbers and their prime factorization. In this case, it is not necessary that the number should be a common number. We need to product all the numbers in the prime factorization, but their greatest power. I hope it is clear to all. You will further understand it in detail and more clear when we solve the exercise question. Let us solve the exercise question. The second question is, find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. What they say is we need to find the LCM and HCF, and we need to verify that LCM to HCF is equal to product of the two numbers as the formula we read earlier. So the first subdivision of the second question is 26 and 91. We need to take the prime factorization of both the numbers 26 and 91. So 26 is equal to 1 into 2 into 13, and 91 is equal to 1 into 7 into 13. Here it is 1 into 2 into 13, and yeah, here 91 is equal to 1 into 7 into 13. So HCF, as we discussed, it is the smallest power of, this is a product of smallest power of common number involved the prime factorization. So HCF is equal to, here the common numbers are 1 and 13. So the smallest power, here all the powers of 1. So smallest power is 1. So 1 into 13 is equal to 13. Here LCM is equal to product of the greatest power of each prime factor involved in the numbers. So LCM is equal to each prime factor involved number is all the powers of 1. So the greatest power is also 1. So 1 into 13 into 2 into 7. It is equal to 182. So we need to verify that now. As we saw in the formula, LCM to HCF is equal to product of two numbers. First, LCM to HCF. The LCM is 182 and HCF is 13. So 182 into 13 is equal to 2366. Also the product of two numbers 26 and 91 is equal to 2366. So the formula is verified. The LCM into HCF is equal to product of two numbers. And also in the case of product of two numbers, 26 into 91, which is equal to 2366. Also LCM into HCF is equal to 2366. So the formula is verified. LCM into HCF is equal to product of two numbers. Let us now move on to the second subdivision of second question, that is 5, 10 and 92. So again we need to take the prime factorization of 5, 10 and 92. Again 5, 10 is equal to 2 into 3 into 17 into 5 into 1, and 92 is equal to 2 into 2 into 23 into 1. So LCM of 5, 10 and 92 is equal to 2 into 2 into 3 into 5 into 17 into 23. That is 23,460. And HCF 5, 10 and 92 is equal to 2. As we saw in the prime factorization. So greatest power, product of greatest power of each prime factor involved in the number, and product of smallest power of each common prime factor involved in the number. That is LCM and HCF is equal to respectively. So again verification, LCM into HCF. The LCM is 23,460 and HCF is equal to 2. So LCM into HCF is equal to 23,460 into 2, which is equal to 46,920. And again product of two numbers, the numbers are 5, 10 and 92. So product of two numbers are 5, 10 into 92. They are 46,000 sorry, 46,000, that is 920, not 620. 46,920. So hence LCM into HCF is equal to product of two numbers. That is verified. Now let us move on to the third subdivision of the second question, that is 336 and 54. Again, now take the prime factorization of 336 and 54, which is respectively equal to 2 into 2 into 2 into 2. That is 2 to the power of 4 into 7 into 3 into 1, and 54 it is equal to 2 into 3 into 3 into 3 into 1, which is equal to 3 to the power of 3 into 1. Therefore, LCM is equal to of 336 and 54 is equal to here. Here we need to take the greatest power of each prime factor in all number. So here the greatest power of 2 is 2 to the power of 4, and here 3 is 3 to the power of 3, and into 7 into 1, which is equal to 3024. And again HCF, here we need to take the common. Here the common numbers are 2, 3 and 1. Smallest power is 2 to the power of 1. So 2 into 3 and again into 1. It makes no change to the answer. But 2 into 3 into 1. So here it is, the answer is 6. So again verification. LCM into HCF. Here LCM is 3024 and HCF is 6. So 3024 into 6 is equal to 18,144. And again product of two numbers. The two numbers are 336 and 54. So 336 and 54 is equal to 18,144. Hence we have verified that LCM to HCF is equal to product of two numbers. Both the case it is 18,144. Hence the second question is over. So I will meet you with the third question of exercise 1.2 in my next video. Until then, bye bye friends. Stay home, stay safe, stay healthy, and also do practice maths. Please subscribe to my YouTube channel Math is Magic, and don't forget to hit the bell icon for latest updates.